So yeah, hi everyone. My name is Stacy. I am a data science intern at Deephaven, and today I just wanted to give you a kind of insight on my summer internship and to share with you my experience with Deephaven and tell you about one of my projects. So yeah, personally, I never used Deephaven before my internship, and most of my coursework projects, data science projects revolved around Python, Pandas, Jupyter notebooks. So when I started my internship, I did not really know a lot about Deephaven as a framework and data engine. But surprisingly, the learning curve on technical side was not steep at all. And yeah, I was really surprised by the quality of technical documentation, user guides, various tutorials. And because of user-friendly documentation and very intuitive UI, getting all the installations set up properly and getting everything to work was really quick and easy. Yeah, I just like it a lot. And as a data science student, I'm very interested in natural language processing, and I was wondering how to harness the power and capabilities of Deephaven in solving NLP problems. Um, so to explore natural language processing with Deephaven, I decided to use Slack as a source of real-time unstructured data. And actually, I had a few ideas for my NLP experiments with Slack data. Um, One of them is social network analysis. It means taking Teams Slack data to see who are the most connected users in the company, who acts as a bridge between the most connected and the least connected parts of network, who has the highest influence on the information flow. So yeah, I think it would be very interesting to explore. Um, Another interesting NLP problem is detecting discussions or implicit threats in the message stream, and then detecting the most popular topics, for example, in Slack discussions. But for my project, I decided to try something a little bit different. I wanted to check if I can use Deephaven to measure the level of toxicity in Slack discussions. So you might know that, well, some recent studies show that that toxic corporate culture is the top reason why Americans quit their jobs last year, unfortunately. And Slack, as the most popular messaging tool on many companies, can definitely be used to spot some signals of toxic culture. Yeah, and I think I need to make a quick disclaimer that, well, this example of discovering toxic patterns in Slack chats has nothing to do with Deephaven work culture. Quite the opposite, yeah. It's very friendly, and as an intern, I was really surprised to learn how smoothly the team works together. Yeah, so now let me show a quick video, to demonstrate how this functionality works. So yeah, basically it's just a test message in Slack, for example, good job. We are making a real-time prediction, and we predict the probability of toxicity in the message, and if this probability is greater than a specific threshold, for example, if it is greater than 0.5, a bot sends an alert to the Slack channel. So yeah, how it was implemented. To get data from Slack, you can use their API, which is very flexible and allows developers to fulfill different use cases. And strictly speaking, Slack provides for different types of APIs that let you move and manipulate data in different ways. So they have real-time messaging API. It is WebSocket-based API that allows you to receive events from Slack in real time. Also, if you prefer events to be pushed to your app instead, they recommend using the HTTP-based events API instead. The web API acts in tandem with the events API. So while the events API sends data from Slack to another source, the web API receives the responses from other sources. Also, they have Conversations API. It offers some additional functionality to make changes to private channels, public channels, direct messages as well. But for my project, it was enough to use only real-time messaging API to pull live data and their web API to post data back in Slack. So to train the model, I used a public data set from Kaggle platform. It contains thousands of Wikipedia comments, which have been labeled manually by human raters for toxic behavior. The dataset has 6 classes, 6 labels that represent different types of toxicity. So text can be toxic, it can contain obscene language, it can be threat, or it can be identity, hate. And to classify test messages, it's possible to use classical machine learning algorithms such as support vector machine or naive Bayes classifier. But well, many experiments done by researchers proved that, well, word embeddings and deep neural networks tend to perform better for text classification. So I used a long-shot memory model with Keras. After training my model on Kaggle dataset, I used Deephaven learn module to apply the model to my live data from Slack and the listener function to listen to a dynamic table with predictions and to be able to send alert every time the table updates. My solution, of course, is very, very far from being perfect, and model makes errors. So, for example, it is unable to predict patterns of toxicity it has not seen before. And I believe that there are a number of ways this solution can be improved. So, for example, to improve model performance, I could add some new engineered features such as the average word length or average sentence length, the number of exclamation points, the number of question points, also capitalization, because, well, toxic comments are more likely to be either in all caps or have no capitalization at all. So yeah, besides, it would be beneficial to use, instead of standard unidirectional long-shot memory model, it would be beneficial to use bidirectional model. Again, because it generally provides better prediction accuracy, because it uses both left and right contexts for predictions. Another interesting approach I would like to mention, and I did not know about it before, it is to use machine translations. So basically, it is just a data augmentation technique that is increasing the size of the training data set. So we can choose a subset of texts and from the training data set and translate them into a different language, for example, into German, and then translate back to English. And such a double translation does not significantly change the meaning of texts, of comments, but it provides some new wordings and it increases the size of training set. And in addition, I think it could be really, really useful to make the system more complex and smarter by detecting not only toxic content, but also detecting passive aggressiveness, some persistent negative humor, or sarcastic comments. And unfortunately, there are a lot of data sets that are publicly available and that can be used to train these classifiers too. So yeah, to sum up, my experience showed that my experience showed that Deephaven software can seamlessly work to solve natural language processing problems, and I think its capabilities can be reapplied to emails, to social media, other messengers, and I don't know, news data, news comments. And it was just only one of my projects. And of course, it does not capture everything that I learned about Deephaven. And yeah, but anyway, it was an interesting experience. And in conclusion, I just wanted to thank you and say that my internship was a really interesting journey, and I'm really thankful for this experience, this opportunity to work with this team which is not toxic, and this team of talented and driven people. So yeah, thank you.
Thanks, Stacy. Any questions? Right. So given your experience, what are some other areas you think Deephaven would be an interesting solution for?
Also, one of my projects was related to healthcare data to predict epilepsy seizure. I think, yeah, definitely Deephaven can be used in healthcare, and yeah, a lot of use cases.
Okay. Any other questions?